Now this illustration deals with cables, raceways, or boxes installed in or under a roof decking. Now I think note 3 is the first thing that's important to look at, but mainly this purpose of change was to clarify the clearance rules of a box being set underneath a flat roof area. But notice note 3 now that says that the spacing is not required where the roof decking is covered with at least 2 inches of concrete slab as outlined in 300.4E exception number 2. And then, of course, the rest of the note 1 and note 2 along with note 4 is just giving you information about this 1.5 inch set off below a flat roof area, and mainly, be on that ridge, and usually you're in pretty good shape. And then note 4 says raceways, cables, or box with listed steel or any kind of iron fittings and boxes are not required to comply with 300.4E and the exception 1 to 300.4E. And that's what this illustration is illustrating to the user of the NEC. Now this illustration deals with the length of 3 conductors at outlets, junctions, and switch points. And mainly it's just to have enough conductor length to make a connection without the length of the conductors being too short. Now the purpose of the change, a new sentence was added to verify the 6 inch or 3 inch rule really. But now if you notice in the illustration, left hand side top of the illustration, we have a raceway and we have a box here. And notice that if you measure from the back of the connector there, basically, it's 6 inches. And that gives you enough if you need to make a splice on a 6 inch conductor measured in this manner. Also gives you enough conductor length to terminate to a receptacle or to a switch. And then notice the bottom, if you're measuring from the very face of the box, as you see here, then it's 3 inches out. And that gives you enough length of conductors to terminate devices, switches, plugs, things like that. And then, of course, as you see to the right, we're just having conductor length so that we can splice. And then notice in a LB, the LB has to be listed and give you the cubic inch rating. Had trouble getting that out. To make your splices. And the same thing with the octagon box that you see at the bottom, or square box, whatever. They don't want an electrician to cut the conductor so short that they have trouble making terminations and servicing a splice that is made by an electrician. So that's what this illustration is illustrating to the user of the NEC. Make sure you have 6 inches, either measured from the back or 3 inches measured from the front, basically will give you enough conductor length to perform your installation. Now this illustration deals with remote control and signaling circuits classification in accordance with NEC 300.26 1 through 3. And the purpose of the change mainly is just to separate the Class 2 and Class 3 from the Class 1. In other words, Class 2 and 3 circuits can be defined and reviewed and so forth in Article 100 and Article 725. But a Class 1 circuit now has its own article, which is Article 724. Now, in reviewing the illustration, you see the individual running the conductor's overhead signaling circuits. Well, this points out they could be Class 1, 2, or 3. Now we have to go to a article that would deal with that, but they're discussed in 300.26 1 through 3. But let's just move over to the square box, and you see all the signaling circuits coming into that junction box. And notice they're Class 2 or 3. And we can read up on those in 725.3A through P. And if you want to know the output and get a good feel for that, just go to tables 11A and B on page 728. The A tables for AC, the B tables for DC. And they usually operate at 1,000 volt amps or less at 30 volts or less. But now if you're dealing with a class 1 circuit, it used to be in 725.41a for a power limited. But now it's in Article 724, and the exact section number is 724.40, approximately page 659. And they operate at 1,000 volt amps or less at 30 volts or less. But now dropping down to your non-power limited remote control with the individual pulling those into that piece of equipment, 300.2 through 300.25 talks about non-power limited circuits. But to get the 120 volt, 208 volt, 240 volt, or 480 volt control that we are used to dealing with, we have to go to chapters 1 through 4 and pick up the respected voltage. And those voltages are mentioned in 220.5 as well as other articles, what would be the normal voltage. Also in Article 100 they're defined. So keep that in mind, and that's what this illustration is illustrating to the user of the NEC, the separation of a Class 1 circuit from Article 725, which will deal with Class 2 and 3, and provide an article of its own for Class 1 circuits, which would be Article 724. Now this illustration deals with general requirements for wiring methods and materials for systems rated over 1,000 volts AC and 1,500 volts DC nominal. And this is a new article, 305. Used to be Article 399, renumbered, relocated. And as you see the note, for the complete entire requirements in this new article, see the following sections 305 through 305.15. And that will give you the rules and regulations of this article dealing with wiring methods and materials. But now, notice one thing, that there are 5 new articles that deal with systems over 1,000 volts and medium voltage type systems. Article 235 is branch circuits, feeders, and services. Article 245 now is overcurrent protection, which used to be in Article 240, the last part. Article 305, we're just reviewing it. It's wiring methods and materials. And then, of course, Article 315 is joints and terminations of these wiring methods. And then 495 is the existing article of 490. So the purpose of this change mainly is just to provide articles that deal with medium voltage and specific types of equipment and devices and components and so forth. Now, used to, we would review the last part of any article, and if there was any high voltage, then the requirements would be listed there, like Article 240, the last part, other articles that deal like grounding, the last part. And basically then these articles with the last part of each article dealt with different components and things that were used in conjunction with Article 490, the equipment that you chose and everything. But that's what this article is all about, and it's referring the user to these new articles to get the information needed to design and install high voltage systems over 1,000 volts. Now this illustration deals with switch and overcurrent protection device enclosures where their splices, taps, or feed-through conductors are present. And basically the purpose of the change, they just added a new item 3 that addresses these requirements where you might have a S-bend, as you see on the panel board. We come in, bend, come up, and bend again, and come into this terminal, this breaker. See, that's an S-bend. And then, of course, the circuit breakers here that you see below the main circuit breaker there, those are L-bends coming in there from the enclosure. The disconnect switch to the right L1, L2, and L3, notice those are Z bends. And to obtain these bends for gutter space, terminations, and so forth, we see our tables 312.6a and B2 that would give us wire bending inches and so forth that we would have to have for terminating conductors, either for S, L, or Z bend. Now, on page 192 of the NEC is where you can pick up these rules. And if you, one illustration, sometimes we do not list the page number because we want you to look it up and get used to using the book. But basically, that's what this rule is all about. It's just addressing bending space when you have a S, L, or Z bend. Now, this illustration deals with screws and other fasteners in accordance with 314.5a through 7, and of course the exception. Now, the purpose of the change was basically not to allow sharp-headed screws, which could cause a short circuit or ground fault as you screw into that insulation and hit the bare copper or aluminum, whatever you may be using. And of course that applies to service equipment, downstream disconnects, it disconnects equipment, pull-through junction boxes, switches, receptacles that you have screws to support them to the box. They should be blunt now. And as these screws become available to us, then we would use the blunt type. However, until they're available and planful to the installer, 90.4 of the NEC allows the inspector to let you use what's existing until the new becomes available. So we'll work together. I can see us all working together from design, installation, electricians, designers, and so forth. So keep this in mind because this is a new requirement. Now this illustration deals with box fill calculations in accordance with NEC 314.16b6. And the purpose of the change mainly is for each terminal block that you see in the illustration, you have an allowance of 1 for each. And in note 2, right next to the equipment there, you see that we do the math for you, and the solution says you have to look at 9 number 12 copper conductors. And in course, the note 1 tells it all. When a terminal block is present, a single volume allowance per table 314.16b1 is required for each terminal block based upon the largest conductor that may be present, is basically what it's saying. And that's what this illustration is illustrating, is you have to count those terminal blocks in there because they take up fill in the box, and we don't want to overfill and cause heating problems. Now this illustration deals with the depth of boxes for 12 or 10 AWG conductors in accordance with NEC 314.12b4. Now notice we have these conductors entering the rear of the box. So you need the room to mount that switch to the box and secure it with your screws, and still have room there so you don't mash the insulation, pinch it, or damage it in some way that creates a ground fault or a short circuit. So note 1 kind of explains what the rule is all about. Wiring enters the center portion of the rear of the box opposite to the equipment in accordance with 314.24b4. And then note 2 expands on the rule and says the minimum clearance should be increased to a ½ inch per section 314.24b4. And so what they're just basically saying, you need this extra ½ inch room to protect conductors and have airspace that would be appropriate for the circulating of heat that might develop, so to speak. And that's what this illustration is illustrating to the user of the NEC. Now this illustration deals for clearances for side wiring entrance And the purpose of this change is just a new subsection to clarify that there is a clearance needed from the side of that switch there where the conductors enter. And what is that clearance? Well, note 2 tells you it's a 1/2 inch, and that's when the wiring is entering from the side. They want at least a 1/2 inch clearance there when you mount that switch, so that you have space there that will not damage insulation of the conductors, and then still have a circulation air gap there, so you have a 1/2 inch. And that's what this illustration is illustrating to the user of the NEC. Now, this illustration deals with a jacket requirement on a cable in accordance with 337.115. And the purpose of the change is to allow a cable with insulation at a certain thickness, more than normal, to be routed without an overall jacket. And as you can see in the call out to the left top of the illustration, it just points out that this is equipment in accordance with 337.115, and the enclosure supplied with a conductor without an overall jacket. And then the note kind of outlines it all. It says conductors in a cable 4 AWG or larger with increased insulation thickness in lieu of a cable jacket is permitted in accordance with 337.115. And that's what this illustration is illustrating to the user of the NEC. Now, this illustration deals with the number of bends in a Raceway Run, one run. The purpose of the change is to outline that you're only allowed 4 90-degree bends in a raceway system as you route it through the system without putting and installing a pull point of the conductor, such as a junction box or a pull box. Now, looking at the illustration at the very top and the conduit run, you got 1, 2 bends, 90-degree bends. We're fine, see. But now, the bottom one, it shows that you have 4 bends that are okay, but then you put another 90-degree bend, which is a violation of the code. And notice, I could have that other bend, but I'd need to put a pull box between 4 and 5 here, so that I would have a pulling point so it wouldn't be such a strain on the insulation of the conductors when I pull the wire. And that's the whole point of this revision that was accepted by the code panel. So that's what this illustration is illustrating to the users of the code. Don't put more than 4 90-degree bends, including a 45-degree offset, see. Now, this illustration deals with PVC encased in concrete, supplying say, an electrical sign in this case. And the purpose of the change is just recognize that PVC can be in the ground and encased in concrete and can be routed from, say, the building structure and panel board out to the sign. The sign has the panel board set because there are a number of circuits feeding this sign of all of the information the sign is providing. So you'd ridge it up at the sign, ridge it up at the equipment, at service equipment, and then run the PVC the distance in the ground that you needed to run it where you ridge it up. And that's all this illustration is illustrating to the user of the NEC, is that you can encase that concrete, say, or I should say the PVC and concrete. And if you want to get more information about this branch circuit, look at 600.5A, D as in dog, and 600.7B6, and I think that's on page 534 and 536 of the NEC, and you can get all the information you know about the sign itself. But that's all this illustration is illustrating to you, is that PVC can be encased in concrete and be used, be routed out there to the sign from the service equipment in the building. Now, this illustration deals with extended distance of auxiliary gutters in accordance with NEC 366.10C, an exception. Now, this rule used to be in the 2020 NEC. It's section 366.12, item number 2. And this was the problem, and was usually considered this way by the electrical industry. But notice the disconnect beneath the auxiliary gutter here. If it does not extend over 30 foot from the side of that disconnect to the end of that auxiliary gutter, it's still an auxiliary gutter. But if you extend over 30 foot, then it becomes a wireway, and your rules for a wireway then kick in Article 376, and you do not go by the rules in Article 366 for auxiliary gutters. Now, we have to know the difference. Now, that's kind of the way the industry looked at a wireway and an auxiliary gutter, when one would be classified auxiliary gutter and the other would not. Now, other review sections is a raceway and nipple. Now, you see the disconnect below the auxiliary gutter. If that's 2 foot or less in length, it's a nipple. You get a 60% fill, and you do not have to derate for current carrying conductors. But the raceway above there, extending from the panel board to the auxiliary gutter, is over 2 foot. So it's a raceway, as explained in Note 4 to Chapter 9 on page 715 of the NEC. Then you have to deal with sleeves. A sleeve is open on both ends, and it protects cables and PVC and so forth. And 300.10 exception on page 171 gives you this information. Then you have a sleeve from a panel board that you see in the illustration that extends up through a suspended ceiling, 10 foot or less in length, connected in one end, open on the other. And 310.5C exception 1 on page 190 deals with this type of sleeve. Now, there you have it. And that's what this illustration is illustrating. What is a wireway? What is an auxiliary gutter? What is a raceway? What is a nipple? What is a sleeve? And when you know the difference in these methods, then you know how to calculate the size and so forth. And that's what this illustration is really illustrating. Now, this illustration deals with flexible bus systems, parts 1, 2, and 3, in accordance with Article 371, and it's a new article. And mainly you're reviewing sections 371.10 through 371.120, and the purpose of change is just accepting this new article. Now, Note 1 is basically Part 3, and it pertains to the markings on such, flexible bus bar. And Note 2 deals with installation rules, such as the related fittings, the connectors, and so forth that make up the system and make it a continuous bus bar from point to point, say. And of course, Part 2, we're dealing here with installation procedures. You're dealing in the boxed in information with 371.10 through 371.60. Now, that's what this illustration is illustrating, that we're dealing with a flexible bus type system. And Part 2, the sections are listed there that deal with particular subject matters, such as 371.20's terminations, 371.60's grounding. In other words, you can just review this and you know the part that you need. You may say, well, I want to know where it's permitted to be used. Then that would be 371.10, use is permitted. 371.12 is use is not permitted. So everything's kind of given there for your use, and it'd be important to review either one of these if you're section numbers, if you're dealing with installation procedures, and that's what this illustration is illustrating.